This edition of the Vodcast is all about learning about the structure of an atom. So today's Vodcast will give a basic overview of the atom and its three most basic subatomic particles. Now, you might have seen this diagram of an atom when you were in younger grades or in previous science classes. It's called the Bohr model, and it was developed by Niels Bohr. And it pretty much comprises a model that we often use to describe atoms in typical chemistry fashion. It's not the most accurate representation of an atom as we know, but it allows us to understand how an atom can contribute to how compounds and other atom interactions occur. It really comprises of three areas. The areas of where the subatomic particles such as the protons, neutrons, and electrons live. The other thing is that it designates the cloud or the orbital of where the electrons live. And lastly, it designates the nucleus, which is where protons and neutrons exist. Now, as we're going and talking about the different structures of the atom, we have to talk about the atomic particles themselves. Now, what do they do? Well, we have three subatomic particles within an atom. The first one is the proton. Now, the proton actually determines the identity of an atom. Now, the thing about protons is that the identity of an atom is based on the fact of the number of protons. So, for example, all atoms of carbon have 6 protons. That doesn't change from different atoms of carbon. They will always have 6 protons. We'll see later on that the number of neutrons and the number of electrons can vary between different elements in atoms. However, they will always have the same number of protons. Now, the next particle was the neutron. Now, the neutron's an interesting particle. What it does is it provides stability to an atom's structure, especially its nucleus. And also, because neutrons don't have a charge, what they do is they actually stabilize the nucleus because protons with their positive charges will actually repel each other. So like charges repel. So having the neutrons in between the positively charged protons helps to stabilize the nucleus and the atom overall. Now, the last subatomic particle we have is the electron. Now, the electron determines how likely an atom is going to react with other atoms. The electron is primarily responsible for the chemical reactivity of atoms and elements between each other. So, electrons, because they live on the outer orbitals and clouds of an atom, they determine what the reactivity and how atoms interact with one another. Now, when we're talking about all these three particles, we have to talk about them relatively. What that means is that because atoms are so small, their actual mass, volume, and charge measurements are really, really small. So we have to assign relative values to each particle. So the first thing we're going to talk about is their mass, because of course, if it's matter, it has to have mass and volume. So when we talk about the relative mass of an atom, we want to think about the structure of the atom in two places, right? The nucleus and the orbitals and the clouds. Now, most of the mass of an atom is actually located in the nucleus. So most of an atom's mass is located in the nucleus. Now, the nucleus actually accounts for overall 99.6% of an atom's overall mass. That means that most of the mass in an atom, again, is located in the nucleus. If you want to think about that even more, protons and neutrons are actually 2,000 times larger than electrons. So that means that they have way more mass than an electron. So because of this, and because to make our calculations useful and having numbers that are large enough that really can show more meaning than very, 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 very small measurements of mass, we actually assign an overall relative mass to these three particles. So we actually assign protons and neutrons as having 1, and we'll learn that this is 1 AMU in future vodcasts. And we actually assign electrons as having 0 mass because the mass of an electron is so small. So again, these numbers are somewhat arbitrary, but they're there for us to sort of understand the structure of an atom as well as its mass and to do other calculations. In future vodcasts, we're actually going to see these calculations in action and how they are applied to groups of atoms and how we count them in a number that we can use in real life. Now, the other thing that when we talk about the atom again is the actual nucleus itself. Now, as already mentioned, the nucleus is comprised of protons and neutrons that are in the center of an atom. Now, because we already established that 99.6% of an atom's mass is in the nucleus, it's actually really, really dense. So what does that really mean, that it's really dense? Well, it means that most of the mass is very, very concentrated inside the nucleus of an atom. Now, electrons, again, live on the orbitals, so they are around the nucleus of an atom. And that's why we typically call where electrons live in an atom. Now, one thing that I can't stress enough is that most diagrams of an atom that get made aren't to scale. They aren't actually what you actually find inside an atom. Now, most of an atom is actually empty space. Now, this picture that I have here is actually really wrong. Even though I'm showing a nucleus and I'm showing orbitals of the electron, it's wrong because, well, the empty space that I have here from my nucleus to my electron orbitals are not correct. Now, if you think about visualizing how much empty space there is in an atom, you're going to have to think about FedEx Field or football stadium. The nucleus in the center of an atom is probably the size of a marble if it's fitted inside a football stadium. So that's a lot of empty space. And we can even think about how dense that atom must be. So, if you were to zoom in on an atom to the size of a football stadium, if you wanted to find where the nucleus is, it's probably the size of a marble in the dead center. Now, the other thing that we talk about with respect to atoms is its relative charge. Each of these particles have a charge that is assigned to them. Charges are typically measured in coulombs. It's a really small number because these are very small particles. But we have assigned a whole number to them to make them a little bit more useful when calculating charges of an atom. So the overall relative charge that we have assigned for these three subatomic particles is +1, 0, and negative. So these charges are arbitrary. Someone had already decided to make protons positive and electrons negative, but you could easily have had history rewrite itself and had them switch. So again, the charge assignment is more of someone coming up with it and deciding that was what things were going to be. But again, all of this is relative because, well, atoms are really small. So we have to make them some way more useful to us in a larger manner. Now, what makes all these particles really, really important? Well, let's start with the protons. Now, the number of protons distinguishes one atom from another. So, number of protons helps us identify unique elements because of the number of protons. Protons don't change. So, their atomic number on the periodic table is actually equal to the number of protons. So the periodic table is how we actually organize all of our different elements in atoms. And that is based on an atom's atomic number, or also known as its number of protons. So an example of that would be that hydrogen has one number of protons. Helium has 2 protons in its nucleus, and calcium has 20 protons. Now this doesn't change. So no matter the hydrogen, helium, or calcium atoms I find in the world, they are always going to have the same number of protons. And that's why the periodic table is used to identify and organize these elements. Now the other thing that's really important is that atoms of the same element, or a specific element, can always have the same protons, but a clear distinction and an important piece of information is that they can have different number of neutrons. We'll learn later what that is called, but just know that protons have to stay the same for a specific element, but neutrons can change as well as electrons. Protons have to stay the same. The last thing to describe atoms is this idea of atomic mass. Because the mass of an atom is concentrated within the center of an atom, the atomic mass is actually equal to protons and neutrons added together. And we'll learn more about the atomic mass of an atom in future Vodcasts. But we can't forget about the number of electrons. So electrons in a neutrally charged atom are actually equal to the number of protons. And that's with keeping in mind that this is a neutrally charged atom, meaning the overall charge of an atom is 0. And we'll talk more about the charges of an atom later on, but typically we have electrons and protons being equal to each other in a typical neutrally charged atom. Well, that's it with some of the basics for an atom. I hope you guys learned or reviewed some things that you might have learned before in other science classes. As we go through this unit, we'll learn more about the mysteries and features of the atom and why it's so important to our study of chemistry. I hope everybody has a great day, and if you have any questions, you can always ask your teachers. Mr. Tran, signing off.